So now we want to start to create the lighting setup for our scene. I disabled the plexus and the particles here because we still have to define those material, and also the background for the moment because we just have a dome light. So if we render this out, we have something like this. Now we want to actually delete our dome light. We won't use an HDR, we will use a 5 live setup. So let's pause the render and hide it, delete the dome light and create the first redshift light. This will be our main light, so let's call it main. Now I want to split the viewport left right. So I will have my camera here and I can orient the light here in the perspective view. So this light will illuminate the core. So we can actually say look through light, choose main and lock the icon. So now we can move the light in a first person view. And we want to place it somewhere like here. I will round up all these values so it will be easier for you to follow. So now let's open a new render, and also always remember to remove the lock, otherwise you will move and bring the light with you. So let's reopen the render view. The main camera is okay, let's see. It's too dark. We are using an area light, but we actually want to decrease the spread to have more like a spot effect. As you can see, by decreasing it, also the intensity is coming up because it's more confined. So we will find the value we want for this spread, let's say this 0.178. And now we can work on the intensity. So let's put it to 20 until we have something like this. Now for the color, let's choose some bright blue value. Let's say 715 on the red channel and 8575 in the green channel. So we will have something like this. Also, we want to display our background back so we can see it in the render. And there will be not much more to see until we set up the other light. Now we want to add some more orange light coming from the left side. So let's just pause the render. And we want to duplicate this light. Let's call it left. We will move the render and go into first person view of the left light. So in here, let's see, we want to place the light inside the background, of course, and let's put it somewhere like here. Again, feel free to create your own lighting setup, or you can just copy the values I have right here. Now for the color, we want to give him some orange value. So let's say 0.79 and maybe decrease this one like 768, something like this. So now hit again the render button and let's see the new light. For this one we want to set the spread back to 1, so it will not act like a spotlight. Now it's too dim, so let's add like 100 unit to this light and see what we have. Alright, it's better, and we can already start to see also the background, which at the moment doesn't seem to have a material because we forgot to assign it. So go on the background geometry node and we want to assign the same material we use for the rocks. So now let's add a couple of more light to fill up our background. Let's duplicate the main light one more time. This will be somewhere on the top of our scene. We will call it top. And like before, go on the first person mode and we want to place it somewhere like here, so it will hit the back of our environment and also on this secondary rock. Now let's refresh the render. So now it's very soft. For this one we also want to increase the spread, not to a full value of 1, but let's say like 0.6. Now, of course, we will need to increase the intensity, but let's first see the result. And let's put some high value like 500. So we are starting to fill up our background a little bit. And for the color, let's slightly change the value we had before. Let's say something like this. So we have another hue of blue coming from here, like if it was an opening at the top of the cave. And now we want to add a couple more light, also like this coming from the top, that will fill the right part of our scene. So let's duplicate this light one more time. This will be our right one. We will need two of those. And let's go on the first part and let's look through that light. So this time we want to illuminate the right part. So let's say we will place the light, let's say here. So we are illuminating this right part. Then we will add our final toward this direction. So let's bring our render back and hit the refresh button. So we are getting the light. Of course, now it's too much. We want to decrease the spread this time. We want it to be more narrow as a light. So let's say that 334 we had before was fine. Now let's lower the intensity to 70, so it will be more soft. And also this time we want to slightly change the color to create some other variation. Alright, I like what we have so far. Maybe it's a little too dark down here, but we will brighten this up by adding a little bit of volume lighting later. Now we want to add a final light to get rid of this dark area up in the foreground. I don't like it, so let's duplicate this light one more time and pause the render. Let's see through this light. And we want it to lighten up this front portion of the scene. So let's place it somewhere like here. So let's hit the refresh button. We probably need to change also the light parameter. So let's set the intensity to 20. And also change the color. We want to be a little more saturated this time. And maybe we can slightly increase the spread. Let's say something like this. So we got rid of that dark part and now it's of a more saturated blue. Now we want to add some volume lighting for the top light and maybe also for the main one. By default in Redshift all the lights are already enabled for volume lighting, but you have to turn the global volume option here on the volume scattering inside the Redshift node. You have to enable it by here. By default, for my case, it's too strong, so I want to lower the global scattering to 0.04. So it will be a little less. And now we have to individually set the light we want to be active as volume lighting. So you select a light and on the light tab at the bottom between the contribution tab, you have this volume contribution. So basically if you turn off this volume, that light will not act as a volume light. So first let's set the top one to 1 and decrease all the other lights. We want to set it to 0 so we can see the result of just the top light. So we do have something like this. And this by itself is too much, so let's lower it to 0.3. And it's definitely better. For the left one, we can leave it at 0. We don't want volume lighting from the red light. We can add a little bit of volume on the main, let's say 0.5. So we have a slight foreground volume. And on the right, let's say maybe just a little bit from one of the right one and 0 on this other one. So now let's go to the Redshift option and maybe we want to lower this up so we can take a regular render instead and it will be quicker. Alright, rendering's done and it's not that bad. Of course, all of this will be later composited inside Nuke. We will export everything with Redshift IUV. But before that, we still need to take care of a few things, and also my scene crashed earlier and I didn't save it, so I needed to recreate my lighting setup. It should be everything like it was before, except for this top light. As you can see, I moved it a little bit on the right to have this light behind this other rock, so this old dark area is a little bit more interesting than before. So the first thing we want to fix is this emission material. Right now it's turned off and it's correct because the core is closed. But let's move on the timeline. Here the core is open and refresh the render. And as you can see, the emission material is still off. Now I do recommend every time you want to switch context in Houdini, always pause the render. I don't know if it's this scene, but I'm not experiencing this problem only with this scene. I don't know if it's this combination between Houdini and Redshift version, but almost every time I want to switch context and my render is active, I get a crash. So be careful with that. I have to say that since the Maxon acquisition of Redshift, the software is great, don't get me wrong, but the integration with everything which is not Cinema 4D is terrifying. Redshift at the moment is the things that make Houdini crash the most, absolutely. I mean, together with Octane, I believe Redshift is still one of the most viable options for GPU render, but it comes with a subscription which is not cheap, and by default we still don't have any texture feedback on the viewport. To make a Redshift texture show in Houdini, you have to force it by editing the parameter of a shader and forcing with the choose texture, and this is ridiculous to my opinion. Anyway, sorry for the little rant. We said we want to tie this emission material to the animation itself. So let's go in the core start geometry. In here, we have the animation slider, which is controlling the animation, and it's going from 0 to 1. We want to tie this to a new parameter that we will call emission, so we want to go inside the point bob, which is controlling the animation, and we want to bind export this animation parameter on another attribute that we will call emission. So now let's hide this render for a second and go to the geometry spreadsheet. As you can see, we have an attribute called emission, which is going from 0 to 1 depending on the animation. So back on the scene view, we want to go on the material context, and inside the core emission material, we want to import that attribute. So we want to use a redshift point attribute to take our emission attribute, and we want to feed this into a ramp. So connect the out color of the emission to the ramp, and we want to set the ramp to go from black to some orange value. Let's say something like this. So basically when the emission value is 0, it will be black. When it's 1, it will be this bright orange. Now we want to get rid of this operation right here, but we want to keep the emission map, and we want to lay down a redshift color composite node. So we can output the ramp into the base color and the emission map into the blend. And we want to set it as a multiply operation, so the dirt area of the emission color will cover our emission value, and we want to set the color composite to the emission color value. Now let's go to the OBJ context and quickly turn off all the lights and hit render again. So now as you can see, we do have some emission, and we want to crank this value up a bit. So in the material parameter, on the emission way, we want to set it as 10. So now we have some very bright value, and do not worry if it looks too white for now, because later on we are going to composite this in Nuke. And if you click on this icon, you bring on the redshift post effects option. Here we can turn off for the time being the colors control. So I can show you that by controlling the values inside our EXR files, we will be able to retrieve all the color information that we want. So let's disable this, close this, and now let's go back to the OBJ level. Also, we want to re-enable the lights, and let's see. So now we do have the correct emission value, but let's close the render and move on with the animation. Right here, the animation parameter is still 1, so the emission is on and it's good. The problem is the emission will turn off again right here at 225 because the animation parameter is 0 again, the core is closed. And if you like it this way, it's up to you. What I want to do is to keep the emission on until the end of our shot, so I can turn it off very slowly here, and it will make the shot more interesting, to my opinion. Before doing that, if you take any render after we switch the core from the start geometry to the end one, the simulated one, you may notice an error in the redshift render and you can't see the core. Now we can fix it very quickly, and this is because if you go in the core render geometry, we are taking the point from the dynamic simulation. If you middle click, it has this instance attribute, which is a string 1. Somehow this instance attribute makes Redshift confused, and I believe it's because Redshift does have an instance or proxy system, and it does use this instance attribute in its own way, but set it like this from a dot network without setting any actual naming convention, it just gives you an error. So we need to delete this attribute, and we just want to drop down an attribute rename and delete this instance attribute. So hit render again, and now we do see our core. So now to fix the emission parameter, we can set up a simple point angle. Let me go back to OBJ level. We will set up a simple point angle where we're going to state that the emission will reference to the animation parameter here because it will be fine. But after 225, it will reference to something else, to some other parameter that we're going to create. So we want to go into the core start geometry. Here we binded the animation parameter to our emission. So after it, we want to lay down another point angle before the copy. Let's call it emission. In here, first we want to create a new float variable that will store our new channel to control our emission. It will be a float channel. We will call it emission, and I call the emission also the variable. So click here to create the spare parameter, and now we can state our condition. So if the frame will be greater than 225, we will state that the emission attribute, it will not reference to the animation parameter anymore, it will reference to this new emission variable we just created. So close the curly brackets and also show the outside. So now we can set this emission to be 1 and we want to animate it. So let's say on 295 it will start to decrease. Let's say until 325 it will be 0 again. So now let's go outside and let's see if it worked. So here is 0 again, so all good, but until here it should be on. And let's also refresh the render, and it's not, it's still off. Now, if we go in the core render geometry, this is what we are seeing right now. And if you go on the geometry spreadsheet, even if we set the emission to be 1 on this frame, we have an emission of 0. And the problem is caused by this time shift, because here we say the geometry always to reference frame 225, which has an emission value of 0. So what we need to do is to delete this time shift, and back on the core start geometry, we just want to create another null before the transformation. We will call this out core height, We want to make it green also. So now in the current geometry, we can take that null instead. So we don't have to apply a time shift because this will be a still geometry. And of course now the copy to point will be crazy because we translated the geometry. So all we need to do is to put another transform here and to compensate by raising it 10 units on the y-axis. So now we do have our geometry behaving correctly. And if you go on the core render geometry spreadsheet, you can see that we have an emission of 1. So hopefully, let's go on the OBJ level. Also, let's hide the background and the rocks for the moment so we can have a quicker feedback. And let's see, here should be turned on, so let's render it. And it is on. And it will start to decrease from here. Let's always refresh the render. And as you can see, it got softer until here should be basically off again. And it is. So we took care of our emission values. So back in the core RNDR, make sure you display the outcore render. And now we want to add the plexus. So let's move on some frame where we should have it and enable it from here. Now we still have to assign a material to it. So let's go to the material panel. Here we just want a regular incandescence material. So take a material builder, and first we want to go in the core emission so we can take the same orange value. Let's take the as a decimal. And let's call this new material plexus. Here we want to delete this standard shader and let's take an incandescent one. We want to plug it to the surface, and on the color we want to paste that orange. So let's hit render and see what we have, and we will have nothing because we didn't assign the material to it. So let's assign the plexus material. Alright, this is something, but we definitely want to crank up the intensity of it. So let's also, for this one, put a 10 value as the intensity multiplier. So we have the same value we have on the inside. And before moving on the particle, which is the final thing we need to tweak, we actually want to use motion blur for this shot. So let's look for a frame where we're supposed to have a good amount of motion blur, like this, when the core will start to open, and let's hit render. Of course, now there's no motion blur, we still have to enable it, so on the motion blur tab, enable the motion blur. And also refresh the render, otherwise it won't be visible. And as you can see, by default we have nothing, because just by enabling the motion blur, you will get only the motion blur you get from a transformation at OBJ level. The core animation, it's inside a geometry and it's a deformational blur, and also the plexus, same thing. So we need to enable deformation blur and hit render again. And you will immediately have motion blur. The problem is it will be certain frames where you will get this kind of artifacts coming from the plexus. It might be different for you. 55 is one frame which has that problem. And to fix that, I believe it has something to do with the sorting index on the scene. On the object that caused the problem, you want to go on the Redshift OBJ tab. Here on the settings and the render tab, you will have this deform particle step. This is relative to how many steps the calculation for the motion blur does. And we want to crank this up to a maximum level. If you hit render again, as you can see, the problem is gone. So now to the particle. Let's display this particle RNDR, and for the moment hide everything else, and on the out context also disable the motion blur for now. Now we want to go on the material context and let's create a simple material for these particles. Drop down a material builder, we will call this particles, And for now, let's just leave it everything as it is, except we want to pull the refraction back to 0. Now back on the OBJ tab, assign that material to the particle RNDR. So here was particles. And on the Redshift OBJ tab, you want to go on particles and enable the render object as particle. Otherwise, we won't see the particles. So let's hide the render for a moment and dive inside the particles RNDR. Also in here, let's create a final null. Or even better, let's drag this one at the last of our chain and display the last node. So here we have our particles. So from the main camera, let's take a render and see what we have. We have giant particles, and that's because we didn't set up any p-scale yet. To set our p-scale, we're going to use a point wrangle. So let's drop one before the transform. Let's call it p-scale. And we want to use the life of a particle to control the size of it. Now, if you go on the geometry spreadsheet, we kept the age and the life attribute of our particles. The age starts from 0 and it grows until a particle dies. The life is the already decided amount of life a particle has. So if we divide the age by the life, we can get a value going from 0 to 1, and we can feed it into a ramp to remap it. So let's create a new float variable. We will call this new age, and we will divide the age by the life of the particles. Now we want to set our p-scale, and it will be a ch ramp. We will call this p-scale, driven by this new age attribute. So let's click here to create this pair parameter, and let's set our ramp. We want to change the type to B-spline, and we want the particles to be 0 when they are born. Then they will start to increase until a certain point, and then they will decrease again until they reach 0 just before they die. So we want a ramp something like this. And we also need to remap this value, because right now the ramp is outputting from 0 to 1. They always are giant particle for now. So before the ramp, let's put a fit 01, and we want to remap it with two new channels. One will be our new min, and one will be our new max. Let's click here to create these pair parameters, and we want to set the minimum to be not exactly 0, but let's say 0.0005, and the new max will be 0.001. So let's refresh the render and see what we have. Alright, we do have our particles. Let's move it to a frame where they done with the scaling animation. So let's say here. So there we have it. Now we want to tweak the material. We want to use an incandescent one also for these particles. So first we want to bind this new age variable we created to a new attribute. Let's call it new age, and also specify the type. It will be equal to this new age variable. So now we have an attribute that we can use to control the color in Redshift. And let's pause the render. We want to go to the material panel. Inside the particle shader, let's delete the standard material. We want to take an incandescent one, plug it to the surface. Let's give it 10 as intensity like the other ones. And then we want to take a redshift point attribute that will point to the new age attribute. Like before, we want to feed this attribute inside a ramp, connect the out color to the input of the ramp, and the ramp to the color of our incandescent shader. Here for the ramp, let's set it to be red to blue for the moment and refresh the render. As you can see, the ramp is working. It mostly shows purple for now. If you crank up the ramp, let's say something like this, you will start to see the two colors. So we want to set this ramp to be from, let's say, white and it will go towards this light blue, maybe less green, something like this, and then it will slowly go to some purple value. Let's say something like this. And also, when you want to have some very bright value, don't use full white, otherwise you won't be able to take out the color back even in compositing. And last, we want to check our motion blur. So for the motion blur to work on the particle, we also need to enable this instance particle blur, and it will be pretty heavy. So let's refresh the render and let's see. So if you zoom in, we do have some motion blur and it's not too much. I like the result. Now the only problem is that if you go, let's say, to the part where the particles are scaling up, let's say here, as you can see, we are not getting the motion blur coming from the scaling animation. This is because, let's pause the render. By default, the particles, if an object is set as a particle, it will use the velocity attribute to calculate the motion blur. The scaling effect is coming from a transform node, so it won't affect the velocity. But there's a way to fake it and add a little bit of motion blur. So let's hide this for a second. And also one thing I want to change on the motion blur option of the redshift node. I want to say the frame position not to be on the center of the frame, but on the start of it. So let's go inside the particle render and let's see. First, we want to split this transformation. Right now we are doing the scaling and the rising all in one node. We want to duplicate this node, and on this one it will be the rising. We want to delete the uniform scaling animation and let's set it back to 1, which was the default value. This other node will be the scaling animation, and we want to delete the translation effect here. Let's put it back to 0. So first we want to scale our particles, and then we want to make it rise. So now we can actually drop down a point velocity node. This node will calculate velocity based on how it's set. We want to say to calculate the velocity from an attribute, and we want this attribute to be our position. Also, we don't want to replace the velocity, we want to add it to the current velocity the particles have. So basically we are telling Houdini to calculate a new value for the velocity coming from the change of the position of these particles. So now if we put ourselves at the right frame, let's say it will start to grow from here. So here we should have some motion blur coming from the position, and we do have it. If we scale this value, let's say of 20, we really start to see the motion blur coming from the change of the position. And the reason I split the transformation is because I didn't want this velocity calculation to be affected by the change in the y-axis. Otherwise, we would have also some streaks coming from the bottom part. So of course 20 is too much, but we actually want to animate this value. We want it to be at its full value when the scaling is start. So let's say our maximum will be 2.5. Create a keyframe. And let's say on frame 80, we want to be 0. Then we want to apply the motion blur also for the ending part. So let's say on 205, it will be 0. And right at the end, let's say 230, it will be 2.5 again, put a keyframe, and after it doesn't matter because the switch will take the empty null. So now let's go back to obj level and enable all so we can have a full render with everything in it. So let's see. Alright, everything seems to working correctly. Also let's check some other place during our animation. So let's see at the beginning. and everything seems good also here. Let's see during the opening. Of course, refresh the render. And yes, everything seems fine. Again, don't worry about the colors, we are going to tweak this a lot in compositing. So all we need to do is to set up the redshift IOV for importing them in Nuke. So we want to go to the out context, and on the redshift node, we have the output tab with the IOV manager. Here we want to create all the IOV we need. So let's click on the plus button and immediately it will create the diffuse pass. So if you do a quick render, now here you have the beauty, which is created by default, but you also have the diffuse IOV. So if you select it, you can see that this is only showing your diffuse lighting. So let's pause the render and create the other IOV. Let's click on the plus button here. For the second one, we want to have our volume lighting. So let's look for the volume lighting and select it. Now let's add another one. This will be our specular pass. So where is it? Specular lightning. Then a fourth one, this will be our reflection lightning, so reflection. So another one, this will be our emission values, so let's look for emission. And finally, a last one, we want to create a cryptomat pass. So here, let's select cryptomat is the last entry. And on the option for this cryptomat, we don't want to use the node name, we want to use the material name. So let's hit render again, and we have our diffuse pass, then the volume lightning. As you can see, we only see the volume effect. We have our specular, the reflection, and the emission. On the cryptomat you will see black, but don't worry, it has the correct material information to be used in Nuke. Let's go back on the beauty pass, and finally we want to set up our output settings. So let's see, the motion blur is enabled. On the sampling, I actually want to use the automatic sampling. I don't care how long does it take, I will leave it to render overnight, so it will be okay. And on the main tab, make sure you have the correct camera to render, so it's main camera. And on the output path, go to common, so here we want to set our out path. I will point it to the render folder of my project, so I will paste here the path, and I will call my file pplanet_tooth.f4, and the format will be EXR. Also, we want to set the frame range to the entire timeline, and we just need to hit on the render to disk. So close the render, and I will start to render this thing out, and we will see you when the render is done. Alright, rendering is done, and I did actually made a few changes and re-render it again. I wasn't happy of the amount of reflection I was getting from the core, so I tweaked the material of it in Substance, and I also changed the seed for this secondary rock to get a more interesting shape, and the seed for the big addition on the background, so I could get this big boulder right here instead of this empty pocket, which in my opinion is more interesting. And also I raised up the light a little bit because it was getting inside the frame during the rising animation. So now that we have our sequence, we can hop into Nuke and composite the whole thing.